In this video, I'll lay out the rest of the forecasting process. And then based off of that, I'll provide you a broad picture of how your assignment from forecasting should look. Okay, so use this video as a stepping stone towards doing your assignment because it has very useful information. And um, only after you review this video successfully should you start completing the assignment. The assignment will not be available to you unless you have reviewed this video. So what you need here is a couple of files so that you can work along with me. One is, of course, your demand management template, the Excel file on which we have been working so far, the same file in which we did the moving average analysis, as well as the exponential smoothing analysis. So we'll build on that. The other file that you should open is the attachment that you see along with this video item. It's called forecasting notes. So it has very precise directions that I shall offer. There is a reason why I'm doing this video um, in the context of a statistics class, because we have already covered quite a bit on regression. This is a great opportunity for you to apply regression in the context of things. And of course, if you look back at your slides for the week, it will give you a broad overview of where we want to be. Okay, so I shall toggle between all of those three areas as we go about in class. So first and foremost, let me open up the forecasting notes. Okay, so as you can see in the forecasting notes, this is where it starts talking about linear regression model as the final intrinsic demand forecasting technique. It's intrinsic because it's still against sales data only, against your time. So 1, 2, 3, all the way till 13 weeks, and you have sales data. That's all you have. You are not using anything outside of the sales data set. Okay, so that's what makes the basic time series regression. Time series meaning your x-axis is time and your y-axis is sales. And this can be a very, very natural process for most of you who are willing to use forecasting in finance, because most of your financial forecasting will be around time series regression, where your time is your x-axis and your stock prices or portfolio prices or stickers or whatever it is in the y-axis. So that is essentially this kind of the process. It's still a very intrinsic model because you're not using anything outside of your original y that you're after, except for the time, which is already there. So what they have done here is they have fitted the linear line into your 13-week sales, and so you can see the fitted equation here. Now this is what you need to do. Under time series, if you go back to your demand management template, okay, if you look into the linear regression model here, what I want you to do is recreate the graph here. Okay, graph with trend line so that you can actually showcase the equation. And then what you want to do is, using the sales forecast as your y variable and the weeks or time as your x, I want you to do your regression from data analysis so that you can get those three outputs again, the one that shows explainability, ANOVA, and your regression coefficients. Right? Exactly the way we have done with basic regression equation. Explainability, ANOVA, and regression coefficients. And then when you actually start forecasting, again, because this is an intrinsic model, and for all intrinsic models, you are comparing against the other ones, right? The previous intrinsic models that we have all drawn, the 2 period, the 4 period, the 3 period, the 5 period, moving averages, the exponential smoothing, they're all intrinsic models. If you recall, we were comparing the forecast values from the 6th period onwards, because that would keep all of those models um, under contention, because the 5 period model's first output is in the 6th period. So I want you to populate these forecasted values, but I want you to write the equation by pulling from regression output. In other words, you will do a cellular reference to be able to write the equation based off of the coefficient values that you see for your regression coefficient outputs. And you would use that to populate all of your forecasts. Okay, so um, once you have that, the rest of this process is the same. Forecast error is your actual minus forecast value, and your absolute percent error is your absolute value of that forecast error divided by the actual value and make it a percent. And then based off of that, you draw your MAPE. Okay, so this is how you get your MAPE for the linear regression process. It's a very straightforward, simple approach. Okay, the only thing that I'm asking you is, and by the way, as you draw your regression coefficients, as you eventually come up with those outputs, when you compare the coefficients, they should be the exact same as you see in this equation from the trend line. Okay, that's line of best fit, that's your regression line. So as you look into um, y equal mx plus b, those b and m should be the same um, b and m values that you see in your regression coefficients. But I do not want you to hard code any of that in the equation here as you write your forecasted value. Okay, I want you to pull from those specific cells that you come up with based off of the regression output. So that's all I want from the linear regression piece of the puzzle. And again, um, the the forecasting notes provides you exactly what you need to do, and you can actually compare the output with these numbers. The only thing that you should be careful about is um, how these numbers are populated. There's a little bit of difference in what I am suggesting versus how this book or the source from which I am providing you this data. And I've provided that as a short note here. When you compute the forecast, that 696.1, that is actually the forecast in the 6th week. Okay, so I want you to put that value in the 6th week row. Okay, in essence, you are going to essentially move this by one row. Okay, move this down by one row, and then everything else will fall into place. All the other numbers will actually all make sense. Okay, these numbers are justified, they are just correct. But this one is a little confusing because it shows up in the 5th row for the 5th week, but it's the forecast for the 6th week. So the way we have done moving average, the way we have done exponential smoothing, we'll do the same exact process. We'll put the forecast in the 6th week. So as you calculate, you should find the same set of numbers. Okay. Um, the 702.8 is something you will not need because that's for the 14th week. We don't need it at this point of time. So all you are doing here is up to the 13 weeks. Okay, so you'll just move those down, the same set of numbers. And then based off of that, you should be able to capture the same exact values, 2.4% MAPE. Okay, and that 2.4% then goes into comparison with the intrinsic models. And now the last one that is left is when you start comparing the And this basically actually tells you how that forecast is calculated. So um, these numbers, the 691.8, that comes, 0.08, that comes from the coefficient of the intercept, and the coefficient of the time period is 0.8352. So for the sixth time period, that's basically how you would capture the equation, and that's what you would want to set up in the uh, in the specific cell that we just discussed, um, as you look at the forecast for the sixth period. Okay, so in that specific cell, C7 is where you will use that equation, and based off of that, you'll get the forecasted value. And you'll do the same exact thing for the others. So make sure that you use the dollar symbol for the coefficients, because the same coefficient has been used. Only the time period value is changing from 7, 8, 9, 10, 11, 12, 13, and so on. So that's what linear regression, the intrinsic analysis piece, is about. Now with the extrinsic analysis, I'll leave this completely to you because it is extremely well defined in this forecasting note. You just follow these notes, the instructions here, the language here, to the T. Okay, and you'll never go wrong. This one is a little bit different from the rest. This is a direct application of whatever you have learned so far in the context of regression. So instead of looking at the week, you're looking into this sales value as a function of these two variables, essentially, right? And so once you run the regression for the first 13 weeks, you'll be able to see the regression output. And as you can see, this is something that you are extremely familiar with. At this point of time, those three parts of the puzzle, the R-square value, the ANOVA output, as well as the coefficients of the intercept, as well as the X1 or the X2. And so understand all of those outputs. And then based off of that, this third piece of the puzzle tells you how to set it up in terms of the prediction equation, interpretation of those equations, and then from weeks 14 through 26, there's some fresh set of values that's available to you, and based off of that, you will um, create the forecasts and you look at the percent errors accordingly on those grounds. And so this is just a little different from the rest of the analysis that we have done. So just follow along with what we have done in this note. The note is extremely specific. Um, Read through these. It will make so much sense to you now that you understand the process of regression, of how it can be applied in the context of forecasting. Same story, as I said before here, this particular note um, makes a different position for the forecast value. This is really the forecasted value for the 14th position. So in essence, as you draw this, you will just move these values one row below, one row down, and everything else. These values are correct. It's essentially comparing that 703.5 with the 705. And so all you want to do is ensure that you plug in the right values. So for the 14th week, the 703.5 should show up here. This should be 703.5. The next one should be 720.1, and so on and so forth. Okay, so that's the only change that I'm suggesting from how the data has been represented in this note. And the rest of that should be routine work, and based off of doing all of those calculations, you should find that the mean absolute percent error, or the MAPE, is 1.5%, which is slightly worse than using exponential smoothing. Okay. If you are to use exponential smoothing for 14 through 26 of that data set. Okay. In the context of the current setup for 1 to 13 weeks, this is probably the best value. Now, let's take a look into completion of this assignment. Okay, so um, that's how you would finish off your extrinsic forecasting part. Okay, and you should be able to compute your MAPE at a 1.5%. Linear regression model, I have already talked to you about. Exponential smoothing forecast, we actually did this step by step, so you have to recreate that for yourself to ensure that you get all of those numbers. Um, moving average forecast. Again, we have done all of these. Let's talk a little bit about descriptive stats, visualization, and summary stats Z, because this is something that has already been done. So the summary stats Z um, tab is essentially something that I have done a video on week 6. Okay, so if you look under week 6 materials, um, data sets, you'll see a video in which I have done this entire process, and you have to um, follow that protocol of creating the z-score and what it means in the context to complete this specific tab. Descriptive stats visualization, you would want to clean up all of this because this was a question. This was essentially um, assignment 2B, I believe, for you guys. And so you already have that assignment in place. And as part of that assignment, if I am not mistaken, you also wrote or summarized the information, right? You had already summarized that information. You already have a summary tab that provides an overview of the descriptive visualization that you have done for me as part of this exercise. So make sure that you bring in all of assignment 2B back here. But in this summary tab, you want to go beyond just the descriptive statistics and add to it the fact that you are now trying to find the best model that fits this specific data in the context of forecasting. Okay. And so on top of everything that you already have done in the summary, what I want you to do is a table. That table essentially does a MAPE, and then I'll do intrinsic models, under which I shall have 2 period moving average, 3 period moving average, 4 period moving average, 5 period moving average, exponential smoothing, and time series regression. They are all part of intrinsic models, right? And then extrinsic, you have a different set. So what you want to do is create a table that tabulates all of the MAPE values here, right? And have a short recommendation of which specific model to use in this context. Also make sure that whatever value you put in here, you can directly hyperlink. Okay, and make a short note that click on any of the MAPE values to see detailed analysis. That way you can hyperlink on any of those values and it takes me to a specific page where I can see the exact analysis. Of course, 2, 3, 4, 5, all of them will go to the same tab. Exponential smoothing will be hyperlinked to the exponential smoothing tab. Um, and then the time series regression and the extrinsic analysis will go to their respective tabs. But they'll all come back to the summary. They'll be connected back to the summary. So the same exact approach that you have done in the past, and that is your assignment. So complete this package of work. I have done some of the work for you. The regression you have already learned, you should be able to apply that in this context, put it all together, visualize it, and summarize the data for me. Excel etiquette, very important. I don't want to see grid lines for the nth time. Okay. Clean up the data, clean up the grid lines, make it look interesting, make it look exciting, make it look something that I would look forward to probing in. Okay, if the summary tab doesn't excite me, then I don't want to go into the rest of your work. Okay, so put some time into it, and that's the only assignment that you have in the context of applying forecasting um, for the time being. And then of course you'll do a case on this later on. But that in essence is what I have on my end